Hello, my friends. Good morning, good afternoon. I'm Felipe Hoffa, developer advocate for Snowflake, and we are live today with Ellery Berk. How are you doing, Ellery?
I'm doing great. Thanks, Felipe. How are you?
I'm good. Super happy to see you. Preparing this live was super fun, so I'm expecting a very interesting conversation. We are live, so we love mistakes, we love accidents. Let's see what happens. Let's see what questions we get from people. Um, Let me check to see that everything is working. I see that, whoa, we have a great number of people already connected. And usually we do this early in the morning for California, but what time is it right now, Ellery, for you?
For me, it's 4:32 p.m.
4:32 p.m. Where in the world?
San Mateo, California, calling in from Snowflake San Mateo office.
Oh, the almost headquarters that are like the headquarters, but not the headquarters of Snowflake.
Yeah.
And today I'm in Tokyo. That's why we're doing this in a different time zone. So if people love this time zone, we might as well start doing this at 4:30. And what are we going to talk about today, Ellery?
So today we're going to talk about Snowflake Cortex and specifically the area that I work on within Snowflake Cortex, which is our ML-based Snowflake Cortex ML-based functions, and we can get more into Snowflake Cortex, but it's Snowflake's intelligent, fully managed AI and ML service that we launched very recently, but that builds on a whole bunch of work that's culminated in our announcement about Snowflake Cortex recently.
Oh, yes. And that's one question that I will ask you in a second, which is how are we launching Cortex now if some of the functions we're going to review already existed? But first, what do you do at Snowflake? Why are you the perfect person to talk about Snowflake Cortex?
Yeah, that's a great question. So I am a product manager here at Snowflake. I joined in January and have been working on this feature set within Snowflake Cortex since then. But before joining, I did an MBA at Stanford. And before that, I worked actually as a SQL analyst for my first 4 years of my career in consulting and truly lived in SQL. I worked in SaaS with some on-prem servers, and it was just really a nightmare. So I feel like I spent my first 4 years of my career building a ton of empathy and just like excitement about the Snowflake premise. And now working in machine learning and trying to sort of make machine learning accessible to folks who love data and love SQL, just like me.
I love it. Yeah, I'm bringing ML to SQL is such a nice thing. Also, almost happy anniversary at Snowflake. It's amazing.
Thank you
You
so
joined in
much.
January. The stuff is going into GA now. Um, this is a great, great place to be. And I'm looking at the comments, the live comments. We have friends from Denver, from Canada, from Texas, more Denver, Australia, Queensland, Nairobi, Melbourne. That's the nice thing about the Asia Pacific time. Being in Tokyo today means we get a lot of comments from uh, a side of the world that I don't usually see here. So that's great. By the way, before we get started, I can prove that I'm in Japan. See, I have this beautiful Japanese peach snacks that I'm going to be eating today. And yeah, so we have, let me show people, you just posted this a couple hours ago, Ellery Berk on LinkedIn, some thoughts on how you can supercharge your work, coffee meets machine learning. You'll be chatting live with me right now about quick, efficient ways to use ML when you're working with SQL and Snowflake, the live stream, the link for the blog. That's awesome. I see some code here, so hopefully you have some demos for us. Also, we have quick starts for people that want to get started quickly and try all of these. And here we have the documentation for the Snowflake ML, Cortex ML based functions. But I'll give you the stage for you now, and I will be also monitoring the live questions because we love questions.
Awesome. Okay. Well, yes. Does it make sense to start with just talking a little bit about what Snowflake Cortex is, and why we're launching it now, how everything that we're going to talk about today fits in?
I love it. What is Snowflake Cortex?
Okay, so Snowflake Cortex is as I mentioned, our intelligent, fully managed AI ML service. And it's an umbrella for a whole bunch of different products. that's sort of the marketing spiel. I would say the way that I think about it internally is Snowflake Cortex is bringing a bunch of intelligence to the way we all work with data within Snowflake, which includes everything from our document intelligence offering, Document AI. So if you have a bunch of documents and you want to extract information from all of those documents in a big batch, Document AI can help you with that. Universal search, also bringing intelligence to the way that we do work in Snowflake, helping you say, not just in the data marketplace weather data, but say, how do I predict demand for electricity next week? And then bringing up a marketplace listing, documentation about our forecasting function, documentation, or maybe, some listings of tables in your own schemas that might be relevant to your work, and on and on. So Cortex really has this angle that helps sort of supercharge the work that we're all doing. And then it also houses a way to bring large language models to Snowflake. And what I have been working on is this area in this screen where it says serverless AI and LLM functions. And the idea here is this is bringing, the power of machine learning and large language models to Snowflake and to SQL users alike, to analysts, in a really convenient and fully managed form. And again, all of this is within the security and governance boundaries of Snowflake and scales with the rest of Snowflake, just as you expect Snowflake to. So there's tons of convenience, all painted in, governance, security, and then hopefully, bringing a bunch of intelligence, and then also giving you the flexibility to build your own stack within Snowflake if that's what you're looking for.
That's great. So we have use AI in seconds with things like Document AI, Universal Search, Snowflake Copilot. We also have Streamlit. That's really big on the Gen AI space. And we also have the OSLLMs, the fine-tuning, the partner LLMs, and the serverless AI and LLM functions.
Yes, and so that's the overview. To dive
By the way,
into,
just to answer one of the live questions, because Karthik in New York is asking, is this is recorded? I think I just answered that question by reading his comment live. Because we have, again, friends from everywhere today: India, Sacramento, Ohio, Arizona. Please, Snowflake Cortex, specialized functions.
So yes, in that square that said Snowflake, serverless AI and LLM functions, we have this set of functions that's on the screen right now, our LLM-based and ML-based functions that are sort of we're calling these our specialized functions. The way I think about these is they're SQL and Python functions well suited for, as this slide says, unstructured text analysis and predictive analytics. To me, that's a little bit generic. The way I think about these is they help you take an input and get an answer back. So if you want to take a bunch of unstructured text and get a translation, you can do that with an LLM-based function. If you want to take a bunch of historical sales data and get a forecast of what those sales might be in the next week, you can use the forecasting function for that. So these specialized functions really are meant to take an input and give you a very specific output and feel extremely familiar and familiar to the rest of the experience you have with Snowflake and SQL. I will mention, so that just to give an overview, the LLM-based functions on the left are in private preview right now. The ML-based functions on the right are in various stages of preview. Forecasting and anomaly detection are in general availability soon, very soon. Look out for an announcement on that one.
I love the holiday gift.
Yeah, exactly. We're bringing gifts to everyone a little early. Top Insights, which is also called Contribution Explorer, is in public preview right now. And then classification is entering private preview, I believe today or tomorrow. Don't hold me exactly to those dates, but this week also private preview. So for any of the private preview functions, of course, feel free to reach out to your account teams. And then for the general availability and public preview functions, those should already be accessible to you. And we are launching some upgrades for forecasting and anomaly detection. If you've already tried them, there'll be some updates getting announced soon for this.
Excellent. So yes, people are already playing with the LLM-based functions in private preview, but I love GA, so getting to the GA stuff is also very, very exciting.
Awesome. Yeah, and I guess maybe the last thing I'll say here is these functions are really intended to help folks who know their data well, know the problem they're trying to solve. They're really experts in their domain, but maybe aren't machine learning experts. We want to make sure those folks have access to the accuracy and sort of transformative power that machine learning gives people. So these are just sort of like convenient wrappers for a whole bunch of best practices and infrastructure management that normally, your data science team might have to do, but you can do now just by using these SQL functions.
Excellent. And I have a question from Vino. I love Vino, one of my teammates. What ML models are being used under the hood for the ML-based functions?
Yeah, great
Are the
question.
LLMs?
Okay, so they're not LLMs. The LLM-based functions use LLMs under the hood. The ML-based functions use more traditional machine learning models. And you can read our documentation. They're basically tree-based, decision tree models typically. I would say today we're using light GBM for a few of these functions. But one benefit of these functions is that we're constantly improving the algorithm under the hood. So we're improving, adding things where, we'll do things like add additional algorithm options, add options that allow you to pass in more training data that are robust to even more scenarios. So while right now we're using a light GBM model for some of these functions, in the future that'll evolve as we continue to improve these. And so you can think about these functions really as sort of like almost like an outsourced data science team, because we're going to continue to take advantage of all of the research that's been done to date in the traditional ML field. Yeah.
I love it. How would you answer this question from Daniel? Which I think it's related. We will have a related answer because it's what's the accuracy rate for each function? And I guess one answer is it will keep improving, but what else can you say?
It will keep improving. I would say internally we do a bunch of testing on publicly available data sets to make sure that the accuracy that we provide is similar to or better than out of the box models like Profit, like AutoArima. I would say I typically don't cite a specific number because it depends on how hard your forecasting problem is. Typically, how hard your forecasting problem is, how well, our accuracy number will fluctuate, as will these other out-of-the-box models or even, competitor offerings as well. So I would say we strive to be as good as or better than, and then also more convenient and, highly performant as well.
Good. And also, this is also an invitation for anyone testing this. Please test it. I love seeing blog posts where people are testing it with their use case, telling us what they think, and showing what results they get with their own data. So please, I would love to see how accurate these results are for anyone testing them. The best part is they're really, really easy to get started, as you're going to show us in a demo in a second. And the last question before going to the demo, because as talking on the LLM-based side, Matt wants to know which LLMs, as he wants to understand what prompts, etc., to use by knowing the underlying LLM.
That's a great question. So since these are in private preview, I think if you have an account team you can reach out to, or if you are using these today, you should be able to reach out to your account team and they can share documentation that lists out the model that's used for each of these. I want to check in with the team before I list them all out in a live stream like this, but your account team should be able to share your documentation and then you'll have the whole list.
Perfect answer. I love it.
Great. Any other questions, or is it time to go to the demo?
I would love to go to the demo, and people will keep having more and more questions. This is
okay.
Everyone loves what they're seeing.
Let me shift over here. Okay, can you see that all right?
Yes, I can see you have, I guess, a demo account because you're using the account admin role that's not recommended for enterprise, but if it's your demo account, it's perfect.
It's my demo account, so
excellent.
I appreciate everyone's patience as I'm using my demo account. So today we're going to do a demo showing just the forecasting function in particular. We actually I have some early access to some of our GA functionality, so you'll see some things that will be available once we announce our GA. And the framing for this is actually the same as the quick start that we have available for our Cortex ML-based functions. So basically anything you see today is available in the quick start in an expanded and more detailed fashion. So this is really just a teaser for what you could do by yourself. The scenario that we're going to demo is we own a line of food trucks called Tasty Bites, and we need to predict how much food, we need to figure out how much food to buy for the next week or so, the next 10 days. So we want to know, okay, how many lobster mac and cheese orders do we think we will sell in the next 10 days? And therefore, how much do we need to buy right now of the ingredients to make sure we can cover all of those orders? Okay, that is the scenario. The first thing we'll do is just look at the historical data that we have. So we have, let's see, date.
Yes.
It's kind of the selection of the data. Okay, we limited to 10 rows. So the selection of the data is a little sparse. We won't look at it in a chart, but we have, basically we have a data set that is a set of timestamps. So a number of, each row is a day. And then we have a total number of lobster mac and cheese orders sold, lobster mac meals sold, which is great. So now we have just a very simple series of historical data. And what we're going to do is we're going to train a forecasting model on that historical data. So I'll kick this off and then I'll explain.
Yeah, I will also ask you how many rows are you training with, just because I'm curious with a select count.
Yeah, that's
because you showed us 10 rows, but we're training this algorithm with the whole table, which is a view, lobster sales, and we're training with timestamp and total sold. Well,
okay.
Easy forecasting. Excellent. That was fast. 20 seconds.
From lobster. Let's see how many there are.
Let's see.
363 rows. So there aren't a ton of rows in this particular data set.
Good. But it will work for the demo.
Yeah. So it's I would say if you think about it, it's about a year of daily data is how you think about it. But maybe you have 5 years of data, maybe more than that. So what we've done here is we've said create a Snowflake forecasting model called Lobster Mac. And we've passed in our lobster sales data. So those 363 rows, we've identified for the model what the timestamp column is and what the total sold, and then which column to train on. So the target is the model that is the column we're saying to the model, please train on this. We want you to predict this into the future. And then we'll create predictions. And what we're saying here is call our forecasting model. So we named our forecasting model Lobster Mac. So we're saying call the forecasting model, and we want to generate 10 predictions. So predictions for the next 10 days of sales.
Perfect. I have a question.
Oh, yeah, go for it.
Yeah. You gave this daily data. So the algorithm is figuring out that the periods are 10 more days? How?
That's right. Under the hood. So the model learns what the interval is between each of the timestamps that you pass in when you train the model. And then it just infers that you want the same interval back for your forecasting periods.
That makes it easy.
Yeah. So if you pass in monthly data, it'll give you months, daily data, it'll give you days, hourly data, same thing. Okay. So the output looks like this. You get a timestamp. Whoopsies. Here we go. Make that a little bigger. You get a timestamp back, and you can see we have 10 rows for the 10 days we wanted to predict for. You get a forecast, and then you get a lower and upper bound. And these bounds are really meant to help you understand how confident the model is in the predictions that it's making. So the wider apart this interval is, the less confident the model is. The narrower, the more confident. There's more information on this in our documentation, but I'll leave it there for right now. Because what's fun about these functions is it's really easy to store the results into a table and then join those results union your actuals, so your historical data with your forecasts. So you can see here we have our timestamp column, all of our historical data, and then all of our forecasted data as well. And what we can do if we add our actuals in here, great. You can see blue is all of our actual data, so our historical sales of lobster mac and cheese, and then yellow is our forecasted data. And since we're, very astute proprietors, we look at this and we say, okay, this actually makes sense. The forecasts aren't too high, they aren't too low, and we think, some fluctuation day to day makes a lot of sense for our company.
Yeah. And also we have a lower bound, an upper bound that we could be charting here. Right now, no, but that's part of the forecasting too.
That's exactly right. Yeah. I didn't add them in when I was making this sort of larger table, but we could join them in and then, yeah, chart all of them.
Excellent.
Great. Okay. So that's a super simple forecasting situation where we took one single series historically, trained on it, and then predicted that series into the future. So
Good.
that's the simple case. There are a number of advanced options as well, like training on exogenous variables. So those are, you can also call those features. So training on not just the historical series that you want to predict into the future, but other variables that you think will help the model better predict your target variable into the future. So that's
Yeah.
one thing. Oh yeah, go for it.
No, just thinking because we gave the algorithm 1 year of data. Of course, it predicted the 10 next days, but it wasn't considering any other variable that could have made us sell more or less.
Yeah.
But we can change that to make even better forecasting. Thanks.
Exactly. It's like, what else in the world can help us make better predictions? There must be something.
Excellent. Let's hear
Yeah.
it.
Another thing that we'll talk about now in this advanced option section is predicting multiple series at once. So what we just did was predict sales for lobster mac and cheese, but we actually sell a ton of different items. We'll look at how you can predict sales for multiple items at once. And then these last two rows here, evaluation metrics and feature importance, are things, parts of this forecasting experience we'll explore to help us understand, one, how accurate are our predictions likely to be? And two, which features are most important to the model? So what sort of, that can help you answer, what is influencing my predictions? What is sort of what helps us explain what happens next the best? So we'll do all of these things, and we think of this as a way to say, okay, if you start with the very simple case, you get a really quick forecast, and then you say, I want more accuracy. I want to be able to explain this to my team. How do I do that? This is one way to do that. Before I dive in, any questions there?
Evaluation is so important. So I have a related question from Vino. Like, first, she wanted to know what models we were using, but then what if you want to have more control of the models you're using? And I think I'll give you my short answer. You can tell me if you agree, Ellery.
Great,
Is
I love it.
we have these pre-made functions that make everything very easy, but we still enable people to just bring their favorite Python libraries and use Snowpark. But you have the details.
That's exactly right. I mean, that's the answer right now, especially. So the core audience that we're trying to help or trying to work with these functions is, the SQL analyst who wants a really good forecast, but doesn't necessarily need it to be at 100%. The 100%, any of the sort of highest priority problems that a team might have are things that we would expect, your data science team to pitch in on. But everything else that sits in the backlog, it takes forever. It's really hard to get the request through. These functions are for that purpose, where you don't necessarily need to control every parameter that's typically available when you're building a machine learning model. And Felipe, as you said, Snowpark ML is a great offering for, training, building machine learning models, deploying them in sort of the more traditional sense.
Cool. So yes, we could have another demo. In fact, probably we have a quick start on how to run XGBoost. If that's what you love. So that's a great point. Like, we have that world. We have covered a lot of custom. Like, do exactly what you want, but we're also offering people these easy functions. So beautiful.
Exactly. Okay. Well, without further ado, feel free to interrupt me, of course. Now I'm just looking at my screen again. So what we'll do first is look at new data to train on. And this time we have 3 different series. So here we're looking at 3 drinks we serve, iced tea, bottled soda, and one of our specials called Mother's Favorite. And again, we have the total number of, each drink sold per day. And this time we have holidays, because we know that when people have a day off, they come shop at our food trucks more. So it's actually really helpful for us to flag holidays to the model and say, hey, sales are likely to be higher on these holidays. You should learn that pattern. So we're including this in our training data so that the model can train on holidays. Cool. And then since we include holidays in training, we also have to give the model a list of when those holidays happen for each of the timestamps we want to predict into the future. So that the model can say, okay, look, there's a holiday on, hypothetically, there is not, but maybe there's a holiday on June 7th in some places. The model would know to increase sales a little bit on that day, given the patterns that it's seen historically. So this time we've got training data, we've got prediction data, and then we'll train a model again. And the biggest difference from before, oh yeah.
No, please. I'm just making sound effects.
Great. The biggest difference here is that we need to tell the model that it should treat our different menu items separately. And we're telling it that this menu item name is the way that it should separate out the training data. So we're saying, okay, the menu item name contains a unique identifier for each of our categories. So make sure you treat them separately. And under the hood, what we do is we'll actually train 3 different machine learning models. We'll train one for iced tea, one for the soda, one for the special drink that we have. But it's all wrapped in this convenience. So you only have to call this SQL command once. So our model's trained, and then we'll generate predictions just like last time. This time, though, we have to pass in that prediction data that contained holidays and identify which column is the series again. So that when we get our output, it looks like this. And you have, let's see, I'll bring this up a little bit. You have 10 rows for iced tea, 10 rows for bottled soda, and 10 rows for mother's favorite. Super convenient. We can run this again to store our results into a table. We have some updates coming in the next soon to some of this syntax. So if you're like, oh my gosh, that's kind of ugly, we agree, and we're working on that. And then, oh, yeah?
Good. I love new SQL syntax. That makes things simpler.
Yeah, we're gonna constantly be making this just a better experience. And so the next thing we'll do is we'll look at evaluation metrics. And so again, these evaluation metrics are meant to help you understand how accurate your predictions are likely to be from the model. So basically, how good are our forecasts? Do we think they're good? Do we think they're good enough to base our purchasing decisions on these? And what we're looking at right now is just a subset of all of the evaluation metrics. We're looking at the mean absolute percentage error. It's one of my favorites, just because I think it's pretty understandable. And what we're seeing is that, okay, for iced tea, our predictions are likely to be, around 87% accurate or have 13% error. And the special drink that we have, mother's favorite, is likely to be 74% accurate. And for us, that's actually a big improvement on our previous forecasting for our Tasty Bites trucks. So we're pretty excited about these. And when I go present this to my team, these are some numbers. In addition to sharing the actual forecast, I'll share these to say, hey, I think this is a pretty good option for us. These are pretty accurate.
Cool. So this goes to Daniel's questions, who was asking, what's the accuracy of these models? Now you have it. The accuracy, the exact accuracy, as we test these models on this specific data, the accuracy will change. It will get better as Snowflake gets better, but also you can measure it. You can get your own numbers. That's awesome.
Yeah, and you can measure it on your data, which is the most important thing. Like, don't take our word for it. Go test it yourself. Yes. And then I know that we are starting to run up on time, but the last thing I'll show here is just how you get feature importance. And basically the question that this is answering is, which features that are either auto-generated under the hood by the model or provided by me are the most impactful to the predictions the model's making. And there's some jargon in this. So you can see aggregated endogenous trend features, lag. What's happening here and what these are describing are in time series forecasting, it's helpful to have features like a rolling average of the last 7 days, or just a lagged value from 7 days ago, because we'll take the lag example. Often, for us, we know that selling on a Monday is very similar to selling on the next Monday. Like, days of week really impact our sales and the sales volume that we see. And so what you can see here is the value from 7 days ago, 14 days ago, 21 days ago. Those are actually all really helpful to the model when predicting what sales will be tomorrow. And similarly, having rolling averages of our historical values, again, are important as well. And if we scroll down, we can see that Holiday, we thought was going to be pretty impactful, but you know what? It's less than we thought. In this case, it's because there weren't a lot of holidays in that 10-day period we were trying to predict, but maybe if we ran it on a longer time period, we'd see that
Yeah.
there's more importance here.
I have to say, I love here that we gave the algorithm certain columns, so certain features. In fact, your fifth column there is that it's user provided.
Yep.
Yes, but then the most important features in this list are features that Cortex figured out.
That's exactly right.
Like it does a lot of experimentation to find what's the most interesting thing, what happened 7 days before, 14 days before, or even the holiday as an aggregated endogenous trend feature.
Yeah, that's right. We're doing, the models really the algorithm is taking advantage of just tons of best practices that have come up through the years in time series forecasting and are wrapped in these SQL conveniences for you so that you can say, hey, I want to forecast, and then get to benefit from a bunch of, work on the open source models that we take, but also all of the adjustments that my team has done to make these as accurate as possible for forecasting.
I love it. So this is not only simple and fast, it's also super powerful because it's doing all this free extra post processing to figure out what can help us with this. Beautiful.
Yeah, that's exactly right. And the very last thing that I'll show, just in case folks start to use these and want to keep track of the models they've built, are if you say show forecast, it'll show all of the forecasting models you've built, the database where it's stored, the schema where it's stored, when it was created, the name. Yeah, so that's just one convenience for you to help keep track if you start to become a power user of these functions.
Cool.
And that's it.
Mm-hmm. That's it. Let's answer the. Mm-hmm. Sorry, I lost you for a second.
Oh, I'm here.
Yeah. Yes. Now I was looking at the questions. So yes, here we have the two models that we created, the version. You can add comments. They are Snowflake objects with the full governance that you can give people access to either see, use, modify. Beautiful.
Yeah, that's right. That's exactly right. They're Snowflake objects. They live with all of your, in a database and schema. They do not yet support cloning and replication. So just be aware of that. That will be coming soon. We'll update our documentation when those are available. But just know that if you're a super power user of cloning and replication, these will not support cloning and replication at the start of GA.
Excellent. So we are a little over time, but we love questions. So let me give you a couple. Varun wants to know if these features are available for the Snowflake Standard Edition.
Yes, these are available in every edition across all clouds, regions. Snowflake Standard is fair game. Then I hope that you get to try them out.
Excellent. What are your thoughts on MLOps? How do I make this, bring it to scale?
Yeah, that's a great question. So I guess my answer will be twofold. One is that these functions are so easy that traditional MLOps isn't 100% necessary. We've built these with sort of data pipelines in mind. So if you want to operationalize these, you can use something like Snowflake Tasks, and that's really enough to bring, if you orchestrate bringing new data in or updating the table that you're training on, training the model, generating predictions with Snowflake Tasks, you can really sort of mimic the MLOps experience without all of the complexity. The second answer is that our sister team, the Snowpark ML team, is building out, a whole MLOps experience within Snowflake. And not today, but in the future, every model that you build with Cortex ML-based functions will show up in their model registry. And today, you should even be able to leverage the feature store that's starting to get built as well. So there's really going to be this really nice intersection of the whole MLOps, traditional ML world with these Cortex ML-based functions. So if you want to use both, you will be able to in the future.
I love it. PT, I don't know what's his question, but he says, create a forecast instance. After create storage, execute that forecast, show the results, validate the data, redo the same for any correction. That seems like the steps. We're also trying to make it simpler, but seems like...
Where the question is, where is it simpler?
I don't know what the question is, but he listed the steps that he saw.
Okay, well, I mean, the way that we think about this is yes, you go through training, prediction, evaluation. But the nice thing is that we've baked in, all of those features, for example, that are auto-generated under the hood. Those you get for free when you use these functions. And our selection of the algorithm also is something that, we spent a bunch of time working on, but hopefully will just work out of the box for you. Same with calculating evaluation metrics. We built the methodology in Surface. Today we looked at MAPE, but you can look at a whole bunch of other metrics as well. So we're really trying to standardize and smooth out the experience. But to the point of this question, there's still some steps that we think are important and that benefit folks from actually walking through. So we've kept those ones for now.
Excellent. My last question before we bring the bear, and I'll let you close with your last thoughts. Rick wants us to repeat, when is this in GA?
Great. So the GA is coming very soon. I would look for an announcement in the next week, basically, from today.
That's a big promise.
So monitor the Snowflake blog, but look in the next week, and if it doesn't happen, you can message Felipe.
It's okay. I love forward-looking statements when we add the may be the next week. Hopefully.
Maybe. It's always a may.
Yes, but
I
it's
would say
very,
soon,
very soon.
Soon is definitely in the cards, and then maybe if I get my way and our team gets our way.
Yes, it would be a great holiday present.
That's right.
And with that, Ellery, any last words, thoughts, things you want people to remember or test?
I think I would just love for people to remember that these are meant to be super fast and easy, and you can use them today wherever you work with Snowflake and SQL data. And we would love to hear feedback. So if you get to try it out and you have thoughts for us, please share. We're super excited.
Excellent. We love feedback. We love questions. We love people joining us live. Thank you very much. And I'll see you very, very soon.
Thanks,
now
everyone.
it's time for the bear.